Answer this question. What is the fastest way to travel from one point to another with only gravity to aid you? Actually, don't answer that yet, because I'm going to do it for you. Before I do, however, you need to know the meanings of a couple of words. Trust me, these will come in handy later. The path made by a point on a rolling object, such as this square, is called a roulette. The path made by a point on a disc that is rolling on a straight line is called a trochoid. If this point is on the radius of said disc, the path is called a cycloid. Back to the question at hand. Traveling in a straight line doesn't get you to point B the fastest. Sure, it's the shortest distance, but that doesn't necessarily mean that shorter is faster. That can be proven if you watch me run the mile. An extreme curve is significantly faster than a straight line, but there's still something faster. Galileo thought the path of least time was just a piece of a circle, but then Johann Bernoulli came along a hot minute later and was like, no, there's something faster, you nerd. Bernoulli was able to prove this using light. Bernoulli knew that light always took the fastest route through different objects, so he kept adding thinner and thinner layers of substances that would bend the light at faster and faster speeds until he found it, the path of least time, the Brachiiiistochrone. I know you're probably thinking, well, how in beans does this relate to roulettes and cycloids or whatever? Well, my curious and probably bored friends, Bernoulli discovered that the Brachiiiistochrone is a cycloid. Wowee. Cycloids/Brachiiiistochrones are the fastest way to move from point A downhill to point B because they keep the perfect balance of short distance and fast acceleration. In order to prove to you that I'm not making this up and that I'm not crazy, I attempted to build a rig to roll marbles down that would show you just how much faster the Brachiiiistochrone actually is. And thus I discovered that I didn't have the correct materials and it didn't work. But Vsauce and Adam Savage did a perfect demonstration of this. Brachiiiistochrone curves also have the strange property that no matter where you begin your descent on the Brachiiiistochrone, you will always reach the bottom in the same amount of time. I also couldn't demonstrate this, but Adam Savage and Michael Stevens can. I sure hope you guys enjoy my video. I'm sorry I couldn't do a demonstration. I really honestly wanted to do it so badly, but poster board has failed me, and it was a really bad idea to try and use poster board in the first place. But anyway, yeah, I hope you liked it. Hope you had a good time. Hope you laughed a little. Hope you cried a little. Bye.